guess it's already recording. Okay, so on 15 here, some of these are just basic kind of components problems. So like I said, we haven't had a lot of time to practice, so just kind of working backwards a bit. Starting at 15. As an airplane descends towards an airport, it drops a vertical distance of 24 meters and moves a horizontal distance of 320 meters. What is the distance covered by the plane during this time? So it drops a vertical distance of 24 meters, so that implies looking downwards here. So we'll say that's 24. What is the, and second vector was a horizontal distance of 320 meters. So horizontal distance, just draw like that. It only asks for the distance, so I guess we don't need to worry about an angle here. We can find an angle if we need to, but isn't particularly important. So our resultant, so the distance covered, we went down this much and a horizontal distance of this much, both of which are values that would be important. This would be like how far it went on a map, but when you throw in how far it descended as well, the actual distance would be represented by our resultant vector here. So here, this is a simpler type of problem. You're essentially given the two components of your resultant. We'll just call this vector C here. But they don't even want to know the angle or the direction, so we don't even have to be there, just we want to know vector C. So since this is vertically downward and horizontal, we can go immediately into the Pythagorean theorem. So vector C, the magnitude of it, is going to be equal to the square root of 24 squared plus 320 squared. And if we wanted, again, they don't ask for the angle, but if they did want to know the angle, it'd be the inverse tangent of the y, 24, divided by the x, 320. So both values that aren't, that are pretty easy to just plug in our calculators and go with. So anytime you're trying to do this Pythagorean step in your calculator, make sure that you're careful with your parentheses and that you're entering it correctly. I'd hate to see somebody get a wrong answer because they didn't enter it properly in the calculator. So only slightly above 320, about 321 meters. And again, didn't ask for the angle, but if they did, that would come out to be a very low angle of about 4.3 degrees, and that would be referring to this angle here. So next one is number 16. Another components problem. So driving up an inclined road, after 2.4 kilometers, so notice the units there, you notice a roadside sign that indicates your elevation has increased by 160 meters. What is the angle of the road above the horizontal? So here, you have to think on your feet a little bit more than in some of the other issues. So 2.4 kilometers, you notice a roadside sign that indicates your elevation has increased by 160 meters. So 2.4 kilometers, as we're making our triangle, 160 meters is obviously this, increased elevation by 160 meters. So that looks like that. Now the 2.4 kilometers, what does that refer to? Is that referring to the hypotenuse? That would be drawn here, or is that referring to like a horizontal component? That'd be a horizontal, or you might think that. But again, it's a little vague in this question. But after 2.4 kilometers, so it's like you're driving up a road. You notice like your odometer has increased by 2.4 kilometers. Is that going to be telling you the actual length up a road, like your hypotenuse, or the horizontal? It'd be the hypotenuse. So you have the hypotenuse and the opposite side. So 2.4 kilometers, and a lot of people were thrown off in the last test when I had one thing in there that said kilometers, and everybody got all mad at me. But that is something that you are just going to have to get in the habit of recognizing just in life. In any class you ever do, you always have to pay attention to what the units are and whether or not anything needs to be converted. So 2.4 kilometers, not a hard conversion into meters, so it would be about 2,400, or would be 2,400 meters that we'd enter there. Now we want to know the angle of the road, theta, that it makes above the horizontal. So when I said we have to think on our feet a little bit more, that's exactly what I mean. Is that we want to know that angle it makes above the horizontal. We have this opposite side and the hypotenuse. So what trig function we want to use, just using trig skills, what trig function we want to use in order to solve for that angle? Well, let's see, this is, if we want to use tangent, we would have the adjacent side, and we weren't given that. We could find it if we really wanted to, but yeah. We'd want to use sine, since we have the adjacent side and the hypotenuse over here. So sine of theta, we know, is equal to the opposite over the hypotenuse. So theta is going to be equal to the inverse sine. We get rid of sine by doing inverse sine of the opposite side, 160, over the hypotenuse, 2400. And we can just plug that in our calculator and be on our way. Nope, that's not right. Forgot a zero. Inverse sine of 160 divided by 2400, and a low angle of about 3.8 degrees. So number 17, another component problem. Displacement vector from your house to the library is 760 meters long, pointing 35 degrees north of east. Okay, so again, sometimes helpful to draw our imaginary little compass. 35 degrees north of east, so there's east, there's north. 35 degrees north of it, it's going to be like that. And the length of this vector is 760 meters. 760 meters, that's 35 degrees. What are the components of this displacement vector? So pretty straightforward, just asks what your x component is, what your y component is. We'll call this C, this is Cx, this is Cy. Your x and y components. So, just kind of a simple plug-in problem, 760 meters times cosine of 35. We have the right angle, it's the angle between the vector and the horizontal. And our y component is going to be the same thing, except for we're using sine instead. This is 760 sine of 35. Again, we just plug those directly in. 760 cosine 35 is about 623 meters, and the y component about 436. Number 18 is pretty similar to the other two, so I don't think we really need to beat a dead horse here too much with that problem. Just vertical and then run 22 meters horizontally. I'm not going to do all of 18, but 22 meters horizontally. Fun gym class activities. Then 4.8 meters upward. What is the direction angle of your total displacement as measured from the horizontal? So we just have 22, 4.8, and for 18, all they want is the angle. They don't even want the full resultant. So the angle, your displacement vector would be drawn like so, and so they'd want this angle. Opposite adjacent, so we use tangents, and inverse tangent to find the angle. Angle will be inverse tangent of the y, always the y over the x, 4.8 over 22. And solve that and you get your answer.